Hello, 8th grade Grizzlies. This is Miss Brown, also known as the voice of your Ed Puzzle. And this is going to be a review for your chemistry test, which is next Tuesday. So I'm going to get some paper and do a few notes, and then we're going to get started with the review. All right, ladies and gentlemen, here we go. All right, so this is chemistry part 2. Okay, and we started this unit talking about trends on the periodic table. Okay. All right, so we're going to review metals, nonmetals, metalloids, and how the periodic table is organized, and then we'll go into valence electrons and counting atoms. Okay, so there are 3 types of elements on the periodic table. There are metals, which is everything to the left of the staircase, everything to the left, with the exception of hydrogen. Hydrogen is a gas. Okay? Then you have your metalloids, which are anything touching the staircase is a metalloid, with the exception of aluminum here. And then everything on the right of the periodic table is a nonmetal. Okay? All right, so we started off talking about properties of metal, nonmetal, and then we talked about metalloids. Okay? All right, so metals, they are shiny, malleable, which means they can be hammered into thin sheets. When you think of malleable, I think of aluminum foil, because aluminum foil is metal. Okay? They are good conductors of heat and electricity. And they are solid. And they are on the left side of the periodic table, and I'm going to use PT for periodic table. Okay. All right, your nonmetals are pretty much the opposite of your metals. They are gases mostly. Okay. They are dull, not shiny. They are brittle, not bendable. And they are poor conductors. Okay. And they're mostly, okay, I said that, mostly gas. And then metalloids, they have properties of both. Okay. Your nonmetals are the right side of the periodic table. And then your metalloids are on the staircase. And when I say staircase, right here. And let me grab a regular periodic table. Okay, here we go. So anything touching this staircase, with the exception of aluminum, are metalloids. Okay? All right, next thing we talked about were periods and family. I'm sorry, not families, groups. Groups and family are the same thing, but let me just say groups for the sake of being consistent throughout the video. All right, so periods. Okay, these are the rows. Okay, and they tell you the number of energy levels. Okay, so there are 7 periods. All right, so period 1 has one energy level, and that's just hydrogen and helium. Period 2 has 2 energy levels. Period 3 has 3 energy levels. Period 4 has 4 energy levels, and so on. So the rows that go across tell you the number of energy levels. Okay? Now your groups, these are the columns that go up and down. All right? These have similar elements in the same group, have similar reactivity. Okay? And the groups tell you the number of valence electrons. And I'm just going to do an E like that for electron. Okay? And let me write it up here. E equals electron. Okay? And then before I talk about groups a little bit, I'm going to talk about valence electrons. These are electrons in the outer most energy level. Okay? So for example, if this is my nucleus and I have protons and neutrons, okay? This is my first energy level. This has 2 electrons. Okay, this is my second energy level. Okay? These are the valence electrons, the ones on the outermost shell. So this is a valence electron, and this is a valence electron, right? So this element has 2 valence electrons. It has 4 total, but 2 on the outermost shell, okay? The valence electrons, this is very important. These determine reactivity. Okay. So I'll give you a second to write that, and then we'll kind of look at some examples. Okay. So I'm going to spend some time talking about valence electrons. All right. We said there were 7 periods, okay? There are 18 groups. 1, 2, we don't talk about these. So this is 3 through 12, 13, 14, 15, 16, 17, 18. There are 18 groups, okay? To determine your valence electrons, you look at the A number, okay? So, group 1 has 1 valence electron. These are your alkali metals. These are super, super, super reactive because they have 1 valence electron. So remember, elements want to have 8 valence electrons in their outermost shell. That's when they're most stable. These only have 1, so they're highly reactive. This francium is the most reactive metal. Chlorine is the most reactive nonmetal, and I'll go over that again in a minute. Okay? So these are very reactive. These are the alkaline earth metals. These have 2 valence electrons. You look at the A number, 2A. So these have 2 valence. They're in the same family, so they all react the same, and they have 2 valence electrons. These are reactive, not as reactive as these. Okay? Because as you go from left to right, your reactivity decreases, and we'll write that in a second. Okay? This is family 13. These have 3 valence electrons. Family 14, they have 4 valence electrons. Family 15, they have 5 valence. Family 16 has 6 valence. Family 17 has 7 valence. Family 18 has 8 valence except helium. Helium only has 2 electrons total. So it has 2 valence and 2 total. It does not have 8. This is the exception, but it's over here because its outer shell is full with just 2. But it is still in family 18, but it has 2 valence. The rest of these have 8 valence. Okay? All right, so let's take a few more notes. So on your periodic table, reactivity decreases as you move from left to right. Okay. Elements want 8 valence electrons. That's what they want. So because of that, okay, so period, I'm sorry, not period 1, group 1 is going to be very reactive. Because they have 1 valence electron. All right. Then group 17 are going to be very reactive nonmetals because they have 7 and they want 1 more. So group 17 are very reactive nonmetals. They have 7 valence electrons, so they want 1 more. Okay. All right, I'm going to pause here. I'm going to look at some examples. All right, so let's just look at a few examples of identifying valence electrons. Okay, so let's look at phosphorus. We're going to look at periods, groups, and valence electrons. So let's look at phosphorus here. Phosphorus is in period 3. Okay, so let's go with phosphorus. Okay. It is in period 3. Okay. It is in family 15, or group, I'm sorry, group 15. Groups and families are the same, but I'm going to say group. Group 15. And if we want to look at valence, we look at 5A. We look at the A, so it has 5 valence. So if we were looking here to see what other elements would have similar reactivity to phosphorus, okay, well, nitrogen, arsenic, antimony, bismuth, and this one here I'm not even going to try to pronounce, these all have similar reactivity to phosphorus because they are in family 15. Now, if I were to ask you what other element had the same number of energy levels as phosphorus, it would be anything in period 3. So, sodium has 3 energy levels, magnesium, aluminum, silicon, sulfur, chlorine and argon. They're all in period 3, so they all have the same number of energy levels. Okay, so you're going to have a question like that on your test. It's going to ask what element has similar reactivity. So similar reactivity is your family, your up and down group, okay, your group, and then same number of energy levels, you look at the row. Okay, you look at the period, which are the rows. All right, so I just wanted to oh, excuse me, sorry about that. Just wanted to go over that. All right, I'm going to spend the rest of the time going over counting atoms. All right, so your rules for counting atoms. Okay, so you do your parentheses first. And then you do your coefficient. All right, so let me do something else over here. If you want to know the number of elements, okay, you count capital letters. Okay. All right, so let's say you have this formula. All right, and I asked you how many elements. Well, there's one of two ways you can do this. You can draw lines in front of your capital letters, or you can just count the capital. So you have 3 elements. Now, if I were to ask you how many atoms, okay, you look at your subscripts, and we're going to do some easy ones and then some harder ones. So you look at your subscripts, and then you add all of your subscripts together. If there is no subscript, it means 1. So I have 2 carbon, 8 hydrogen, and 1 oxygen. So I have 11 total atoms. Okay, let's do this one. H2SO4. Okay, so what I like to do is I draw lines in front of my capital letters. So I have 1, 2, 3 capital letters. So I have 3 elements. Now I want to know how many atoms. Well, if you look, you add your subscripts. So sulfur has no subscript, so that means 1. So I have 2 hydrogen plus 1 sulfur plus 4 oxygen. Okay, so I have 7 total atoms. Okay. Let's do a couple more. Let's get into something with a subscript and a coefficient. Okay, so I want to know the total number of elements, and I want to know the total number of atoms. So the first thing I do is I draw lines in front of my capital letters. So I have 1, 2. So I have 2 total elements. Now I want to count my atoms. Well, I have a coefficient. I don't have any parentheses, but I have a coefficient. So this is an easy one. The coefficient gets multiplied by each subscript. So I would have 4 magnesium, and I'd have 12 oxygen. Okay, This is probably the most difficult one you'll see. Okay, so first thing I do is I draw my lines in front of my capital letters. Okay, so my number of elements, I count my capital letters, and then we're going to do total number of atoms. All right, so capital letters, I have 1, 2, 3. So I have 3 elements: aluminum, iron, and oxygen. Now, I have parentheses, so I got to do those first. So we're going to ignore this for just a second. So my 4 applies to my iron and to my oxygen. So what I'm going to do is rewrite my equation. So 4 times 6, so I have a total of 24. And then 3 times 4 is 12. Then I bring down my aluminum. Okay, so now I've rewritten my formula. Okay, so now the 2 gets multiplied by everything, all the subscripts. So my aluminum, I have 2 times 3 is 6. My iron, I have 2 times 24, which is 48. And then my oxygen, 2 times 12 is 24. And then I would add all of that up together, and we wouldn't give you anything this big. I just kind of picked some numbers. My total atoms would be 78. Like I said, we would never give you anything this big, ladies and gentlemen, but I just was picking numbers there. Okay? All right, last thing I need to go over is the law of conservation of mass. So basically the law of conservation of mass basically says I have to have whatever I start with is whatever I end with. So my reactants and products must be equal. Okay, so for example, I have this equation. I have Ca plus Zn CO6. Okay. Okay, so let's say I have 10 grams of this plus equals, I have 15 grams plus 15 grams. Okay, so my reactants and products have to be equal. Okay, so I have 30 grams total over here, and this is kind of like math. This is my X plus 10. Okay, so I want to know how much over here, because these have to be equal. So basically you just do like math, subtract 10 from both sides, and my question mark is 20 grams. So if I put a 20 here, this is 30, this is 30, it's equal. Okay. All right, just real quick before I go, I want to review protons, neutrons, and electrons. Protons, that is your atomic number. So your protons will never ever change. Your protons tells you your protons is your atomic number tells you your protons, and it's very important. The protons give you the identity of the element, and they are in the nucleus. Neutrons, no charge. They are in the nucleus. And remember, protons are positive. and your protons and neutrons gives you the mass. Okay? All right, electrons. These are negative. They are in the energy levels. They have little mass. So protons and neutrons are about the same size. Electrons are tiny. So they're much smaller than a proton. Okay? They're in the energy levels. And then the valence electrons, which we went over, but I'm going to go over it one more time. These determine reactivity, and the valence electrons are the electrons in the outer shell. Okay, so remember that. So I'm going to draw one more example of like a valence electron. So if this is my first energy level, these here are the electrons in the outer shell. These are the valence electrons. So that would be this one, this one, this one, and this one. Okay? All right, and one last thing I want to mention, because you do have a question about this on your test, is chemical reactions. Okay, and let me go grab another sheet of paper and we'll go over chemical reactions. So a chemical reaction has occurred if you have a new substance. And that means what you start with isn't what you end with. So anytime you burn something, for example, wood becomes ash. Ash cannot be made back into wood. So that is an example of a chemical reaction. A rusting, so metal, that turns into rust. Rust is a totally new substance. Okay, so whenever you see something about bubbles, something has burned, two liquids mixed, you get a solid. These are all evidences of a chemical reaction, because you do have a question like that on your test. Okay. All right, ladies and gentlemen, on behalf of Ms. Ludeman, Ms. Smith, Mr. Winter, and Ms. Ford, this is Ms. Brown. We believe in you, Grizzlies. Please go over this video. It will help you understand this material and be prepared for your test. Go 8th grade Grizzlies.